Hi, second grade engineers. It's Miss Mulcahy here in our Project Lead the Way classroom. And boy, is it empty here without you. I was thinking over the weekend about the fact that we never got to test the coolers that you spent so much time designing. So I decided today, since there's no one else here, to come in and set up your experiment and test your design with your popsicle. So I have set up our experiment. We're going to be putting a few boys and girls coolers at a time under the heat lamp to simulate that hot summer day that our friends have in our story, and the fact that they need to keep their popsicles frozen during their soccer game. I even wore my soccer shirt today. So let's take a look first at our experiment. You'll notice that I set up the lamps and measured the distance to the edge of each of the lamps. And if we look at this lamp first, how many inches is it from the floor? If you said 20.5 inches, that's correct. Now, I put both lamps this exact same distance from the floor, as you can see. And remember, when we're using a ruler, or in this case, a yardstick and a meter stick, we always start at the end of the measure and increase in numbers until we get to the point where we are measuring to. Now, this lamp over here is hung at the exact same height, but if you look closely, what's the measurement on that lamp? If you said 52 centimeters, you're correct. 52 centimeters and 20.5 inches is the same distance. So we're going to go ahead and get started. I'm going to go down to the freezer, get your popsicles, put them in your cooler, and we'll get started. Okay, we're ready to get our cooler test ready. Now I've put the thermometers under each of the heat lamps so we can double check that the temperature is simulating a summer day. And if you'll notice the temperature in degrees Fahrenheit, look at the top of the thermometer right here by this red mark. And you'll notice that the temperature is about 90 degrees. And if we look at the other lamp, just to make sure that's about the same temperature, we also have approximately 90 degrees, which would be quite a hot summer day in Windsor. So I've put popsicles in each of these coolers. We're going to slide the coolers under the heat lamp and set a timer for 1 hour. So our experiment's all set up. We'll be back in an hour to check the results. It's time to check our cooler. So I'm going to open this cooler. And you can see inside the insulating materials and the other materials that this student used. What we're going to do is open the popsicle and pour the liquid into a graduated cylinder. A graduated cylinder is meant to measure volumes of liquids, and we use it similar to the way we use a ruler. We would start at the end, right down here, and look at the milliliters. Milliliters are how a graduated cylinder is measured, and we would go to the first unit of measure right here, and you can see that that's 10 milliliters. Up here, we see 20 milliliters. So the units of measure in between, let's count and see how many units are there in between. There's 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's 10. Each of these represents how many milliliters, each of those lines. Pause for a moment and think about that. If this is 10 milliliters and that's 20, what do each of those lines represent? If you said 1 milliliter, you're correct. So the unit, this is about how many milliliters of liquid melted from this popsicle? If you said 15 milliliters, you're correct. The rest of the popsicle remained frozen. And opening the second cooler, I also poured the liquid that was melted into this graduated cylinder. Let me focus that for you. And you could see the amount of popsicle that melted from solid to liquid is less than 10 milliliters, meaning more of that popsicle remained solid. Let's take a look at the difference in the coolers and the insulating materials. So this cooler had several insulating materials. It had this thick foam, also some bubble wrap, additional pieces of foam and cotton, and it was surrounded by white cardboard. And I believe this cooler belonged to Christina and Liam. So those were the insulating materials that they used. This cooler also had the white cardboard box design, but the insulating materials were a little different. We had some aluminum foil, some brown cardboard, popsicle sticks, and cotton balls. Are there any materials that you think may have been a conductor rather than an insulator that caused more of the popsicle to melt from this cooler? Okay, it's time to open this cooler and see how our popsicle did. We're going to pour any solid that became a liquid by changing its state of matter into the graduated cylinder. Let's see how we did. This popsicle did not have any melting that happened. When I opened it up, I saw that there was a little bit of liquid inside of the wrapper, but not even enough to pour into the graduated cylinder. So let's look at the insulating materials of this cooler. We have a cup on the outside. There's a tube wrapped in a piece of foam on the inside, and right down there is where the popsicle was able to rest. So it looks like these materials did great at insulating that solid. Congratulations. This cooler, when I opened it, the popsicle in this one, let me just unwrap it for you. Oops. Was also, sorry about that, was also completely frozen. It still had a few drops that have become a liquid, but the insulating materials in this cooler also did an excellent job. Bubble wrap on the outside. The main structure is built with popsicle sticks held together with duct tape. And then on the inside, for extra insulation, this group used a piece of fabric held together by duct tape, and also had a lid on the top of it with this handy dandy little handle. As we open this clamshell cooler, you can see it's a paper plate. The insulated edges are made up of cotton balls, and the bottom of it is an aluminum foil pie plate. So let's see how this popsicle did. I spilled a little bit of liquid when transporting it into the graduated cylinder, but you can see there's less than 10 milliliters of liquid. I'd estimate probably 5 or 6 milliliters. Good job. This cooler has a foam plate as its base and a homemade box. Inside of the box is a cup lined with an aluminum foil interior. And let's see how this popsicle did in the heat test. I don't think there's any liquid. Let's open it up and double check. Just a couple drops of liquid on the interior, but it looks like nice job with that cooler as well.